We have covered tons of topics from advanced microservices patterns to scaling systems. But today, we are stepping into the foundation of all that, the core software architecture patterns. Whether you are developing your first app or leading a complex distributed system, these patterns will give you a framework for building scalable, maintainable, and future-proof software. I will break down the key software architecture patterns that every developer should know, from onion architecture to event-driven to modular, with some real-world examples to help you understand how this works in practice. And by the end of this video, you will have a solid understanding of how to structure your software, no matter what you are building. So, what are we waiting for? Let's get into it. First up, we have layered architecture, one of the most widely used architectural patterns out there. You might have heard it called N-tier architecture. The idea is simple. Organize your app into logical layers, where each layer has a clear responsibility. It's like breaking down the system into bite-sized chunks, each focusing on one thing and doing it well. You'll usually see this in three main layers. Presentation layer is where your user interface or APIs live. Business logic layer handles all the core functionality of your app. And the data access layer is responsible for managing communication with your database. So let's say you're building an e-commerce site. The presentation layer is responsible for displaying product pages. The business logic data layer takes care of things like calculating discounts or processing orders. And the data access layer? Well, that's your connection to the product inventory database. This pattern is great for enterprise systems. It keeps things modular, and if you need to make a change in one layer, the others stay intact. It makes maintaining and scaling application much simpler, especially when different teams can focus on different layers. That said, it's not perfect for everything, especially as your system gets more complex. Now, let's talk about onion architecture. Picture an onion, right? Multiple layers with core in the center. The idea here is to keep your business logic isolated at the center, protected by layers like infrastructure and APIs on the outside. Everything depends on the core, but the core doesn't depend on anything outside of it. Imagine you are building a banking app. At the center of the onion, you have transaction processing and account management, the pure business logic. The outer layers handles concerns like how this logic is exposed via APIs, how data is saved to a database, or how it's presented on a website. The major advantage of onion architecture is that it makes your core logic easy to test, extend, and refactor. You can change external technologies like switching database without modifying the core business logic. This is a great pattern when your application needs to evolve and change over time, but you want to keep your core logic stable. Hexagonal architecture is similar to onion architecture, but it takes a step further. The key idea is that your core business logic shouldn't directly depend on external systems like database or external APIs. Instead, it interacts with them through ports or interfaces and adapters, which are the implementations that handle the actual communication. So let's say you're developing a payment system. The core system handles the payment logic, validating cards, calculating totals, etc. But it interacts with external payment providers like Stripe or PayPal through ports. So if you ever need to swap out Stripe for PayPal, you just switch the adapter without touching the core logic. Hexagonal architecture is ideal for applications that integrate with multiple external systems or need to evolve over time. The separation ensures that the core business logic remains pure and testable, and external dependencies are swapped in and out via adapters. Next, let's dive into modular architecture. The idea here is to break your application into self-contained modules. Each module is responsible for a specific part of application's functionality and communicates with other modules via well-defined interfaces. In a content management system or CMS, you might have separate modules for user management, content creation, and SEO optimization. Each module operates independently but can integrate when needed. For instance, the SEO module might interact with the content module to apply SEO roles to blog posts. By keeping your code modular, you make it easier to extend and maintain. Each module can be developed, tested, and deployed independently, meaning teams can work in parallel. And as your system grows, it remains manageable because no single module becomes too complex. Now, let's explore microkernel architecture or plugin architecture. This pattern starts with a minimal core system, and you add features by developing plugins or extensions. The core provides the essential functionality, while plugins handle more specialized tasks. Think of IDE like Eclipse or IntelliJ. The core system provides basic text editing and project management. But if you need to develop in Java, you add a Java plugin. If you want to connect to a database, you install a database plugin. Each feature is added as needed without bloating the core. Microkernel is great when you need extensibility. systems that grow over time or have features that vary between users like IDE tools or CMS platforms benefit from this architecture. You start small and add functionality as needed. Next up is event-driven architecture, a pattern I have covered in a full video previously where I went deep into real-world use cases and examples. But here is a quick overview. This pattern is perfect for systems that need to react in real time. Instead of services calling each other directly, they produce events when something important happens, and other services consume those events asynchronously. For instance, in an e-commerce system, when a customer places an order, an event is generated. The inventory service consumes the event to update stock. The notification service sends an email confirmation, and the analytics service tracks the sale. Each service works independently by reacting to events. Event-driven architecture is ideal for creating decoupled systems that scale easily. And if you want to see this in more detail, be sure to check out my full video where I break down how it is used in real-world applications like Uber and Netflix. Now let's dive into CQRS, which stands for Command Query Responsibility Segregation. I have also made a full video explaining how CQRS works with examples from banking systems to event sourcing patterns. But here is the gist. CQRS splits your application's write operations or commands from read operations, which are queries, allowing each side to be optimized independently. In a banking app, the command side handles account updates, processing transactions, while the query side shows their transaction history or account balance. This separation allows you to optimize both read and write operations independently, improving scalability. CQRS is particularly useful when reads far outweigh writes, or when different parts of your system need eventual consistency. For a deeper dive into how CQRS works and how to apply it to your systems, do check out my detailed video on this topic. Next is Service-Oriented Architecture or SOA. In SOA, your application is made up of services that communicate over a network, usually via SOAP or REST protocols. Each service represents a specific business function, like billing, inventory, or customer management. So in a large retail company, SOA might include services for inventory management, order processing, and billing. These services are loosely coupled and interact over a service bus. This allows each service to scale independently. SOA is perfect for enterprise systems with many interdependent components. Each service is autonomous, making the system more flexible and scalable. And finally, let's look at clean architecture, a pattern popularized by Uncle Bob or Robert C. Martin. In this pattern, the goal is to ensure that your business logic is independent of external frameworks, UI, and databases. Just like onion architecture, here the dependencies flow inward, ensuring the core logic is isolated. For example, in a task management app, the core handles tasks like creating, updating, or deleting tasks. External layers handle concerns like the UI or data persistence. So if you switch from a relational database to a NoSQL database or from a web app to a mobile app, your business logic doesn't change. That's the strength of clean architecture. Your core functionality stays stable no matter how much the external world evolves. Clean architecture is perfect when you want a system that is easy to maintain and adapt over time. It ensures that your core logic stays untouched by changes in UI or infrastructure. So there you have it. 9 important software architecture patterns that every developer should know. Layered architecture is great for organizing code into logical layers. Onion architecture keeps your core business logic separated from external systems. Hexagonal architecture ensures your system can easily adapt to new technologies. Modular architecture breaks down your system into self-contained modules. Microkernel architecture starts with simple core, then adds plugins as needed. Event-driven architecture is perfect for handling real-time events in decoupled systems. CQRS separates commands and queries for better performance. SOA lets you build independent services that work together seamlessly. And clean architecture makes sure your business logic stays the same even when external systems change. These patterns aren't just theories. They are practical tools you can use to make your software more scalable, easy to maintain, and flexible. And if you're interested in diving deeper into any one of these patterns, do let me know in the comments. I would love to create more detailed videos based on your request.